So, thank you for the warm introduction of Project Elderwood, Overlook. So we have Project Elderwood, which is kind of the more encompassing term. And we have Overlook, which is, I will be using them a little bit interchangeably in this talk. And this project, as Chris just mentioned, is featuring Natsura, which is a foliage modeling system. So this is an announcement for Overlook. It's going to be an overview and a sneak peek at some work in progress content. So please be nice. It's all work in progress. It's all going to be coming soon, but this is nothing is in the final state yet. And then we have Natsura, which is a third-party foliage modeling toolset. We are very enthusiastic about it. We will do a little bit of a deep dive, and that's going to be a big part of this presentation. It's going to be a little bit of a two-parter where we have Overlook, and then we dive a little bit more into Natsura. But now I'm gonna take it away with a little intro video.
Welcome to a very early preview of Project Overlook. My name is Ethan Olson, the lead artist working together with Side Effects and two legendary partners, Feike and George. Project Overlook takes place in an ancient sanctum surrounded by mystery, a magical past, ruins, and knowledge. The style is a mix of Art Nouveau, touches of brutalism, and heavy influences of traditional fantasy, coined Elder Arcanum. Project Overlook's goal is to bring to life high-quality and intimate scenes using Houdini. We'll do this by showcasing procedural exploration, art directing, and demonstrating what it means to balance bespoke asset creation partnered with procedural tooling in Unreal Engine. In the past, Houdini has been known for being a powerhouse of proceduralism, but it's usually showcased in a large open-world setting. So over the course of this project, we'll continue to demonstrate just how nuanced and high quality you can go when leveraging Houdini and Unreal together.
All right. Now, the team. We are currently working with 3 members. We have George Hulm, Ethan Olson, and we have me, Feike Postmes. And I'll just introduce us very quickly. We have George, who is also developing Natsura. He started out in Unreal, doing some mapping and modding for Unreal Tournament. He has his own Houdini YouTube channel with lots of very interesting tutorials if you want to learn more about some Houdini and Unreal focused workflows. And this guy has basically been thinking about how to model plants for over 6 years. He knows a lot about plants. We have Ethan Olson. He is a lead senior environment artist. He's soon to be a dad. He's a gym rat and a gamer. He can't wait for Path of Exile number 2. And he just has a bunch of experience. Very happy to be working together with Ethan. And then we have me. I'm also working on the development of the foliage modeling toolset Natsura. I'm the co-founder of DodoDevs, which is a company based in Japan. I met George while I was working for Applied Intuition, which is a autonomous vehicle company. Basically what they do, they have large data sets. They help with simulation software, training self-driving cars. This is where I met George. And this is around this time, also mainly at Project Pegasus. This is where George basically convinced me to start working on plants with all of his enthusiasm. Now, the goal of Overlook, we are going to try to push some of these boundaries that we currently feel when we're using Houdini inside of Unreal. Maybe some of you already worked a little bit with Houdini Engine, trying to get stuff inside of Unreal. And sometimes, depending on what you might be doing, this might feel a little bit clunky. And we really want to smooth out this process. So we will have an overview at some of the work in progress work that we've been doing. And we're going to push the integration of this Houdini workflow into Unreal. And we were looking at scriptable assets, scriptable tools, for example, which is a system inside of Unreal to really basically be the duct tape to keep all of our tools together and working nicely. And then, of course, we have some foliage modeling workflows, which we're very excited about to really bring foliage modeling towards the next stage. So, another marketing project from SideFX. Very happy that SideFX is doing this. It's going to be Unreal 5. Hopefully the latest stable version we can get our hands on. We will be using Houdini Engine and we will be using scriptable tools. So what will the scriptable tools do for us? We have two small examples right now that we have. We have a simple placer where basically you don't have to place your HDA by hand in the scene anymore. It's a little bit of a wrapper around the Houdini digital asset, which instantiates it for you into the scene. And it can provide some easy handles to do some basic placement or to set some basic parameters. So you don't have this messy interface, but just a clean, nice interface to work with. And then we have a voxel scene sampler, which we're very happy about. And this voxel scene bridge, basically what it does is we use some native Unreal implementations to get basically voxels out of the environment. Some of you might have been working already with Houdini and Unreal. And one thing that is really nice to have is the environment to get it back into Houdini. But usually when you do this, you are manually selecting all your objects. You're also transferring all of those objects to Houdini. Maybe you selected one less. The result coming out of your Houdini asset is now also different. This is not always ideal. And we really want to streamline this. So instead of manually selecting all this stuff, we have a little script which basically samples the scene, generates voxels, and those get sent to Houdini. And then we make an SDF, a signed distance field. We really like signed distance fields, especially when we're working with Natsura. So it's a signed distance fields and it's a VDB. These are two different or the same mechanics. So a signed distance field is basically if you imagine a point grid, each point contains the distance which is most nearby to the nearby surface. And the same is for everything that's inside. Those will have negative distances. And this is one way to represent, for example, geometry or objects. And this is a very, very powerful way to represent your objects. And where VDB comes in, this basically means that we only have the active points that we care about. So there's a lot of emptiness in the scene and we don't send over the entire volume of the entire scene because that would be very, very large. And some of the stuff that we really like to use this for is for phototropism and figmotropism, as Natsura has a foliage modeling toolset. I will go into this a little bit later. and basically doing light simulations or getting thigmotropism, which is how plants interact directly with objects. This is where we're very interested in this SDF. And because we are doing this with the voxel scene bridge, we basically have instantaneous access to all of this information, which makes it a lot easier for the user to use. Now, here are some results of the guided simulations we've done by just clicking around in the scene and placing plants, making sure it reacts to where there's more light. It reacts to the object to figure out where it can grow. And of course, we have some form of collisions. That's also what we use the SDF for, which is going to make it a lot easier to get this very, very reactive and interconnective foliage inside of your game. So you don't have to jump in different softwares too much. This is where Natsura is basically coming in. So what our plan is to have these procedural assets made by the Natsura toolset. And we are focusing on making sure that you can do lots and lots of iterations. So you can place your foliage inside of the scene. You can see how it reacts to all your buildings. And then you have parameters you can play with, or even splines to move it in the exact shape that you want. And then later you can bake it. So basically to make that whole process as smooth as possible. We have some more explorations, which we can't show that much about yet. But we are going to try out Copernicus for texturing as well. We want to, again, like I mentioned previously, we really want to make this an artist-friendly experience. Also keeping the scene a little bit slower and everything easy to download is on our mind. And just in general, making life easier for the artist using Unreal and Houdini and that bridge in between. Now, we're going to switch a little bit to Natsura, which is a third-party foliage modeling toolset. And what is this? I am very happy that the previous presentation was about Apex, so I have to explain a little bit less regarding what it is, because our toolset is also built on Apex. So this is a foliage modeling framework. The plan for Natsura is not just to generate one type of tree or one type of plant. It's really about any branching structure you might encounter. We want to try to have this parametric modeling vibe that lots of tools have, where you have some cool sliders, cool settings, which help you to get to the end result. But also we want it to be simulation based. And the reason why I want to do this is because in our experience, we have these parametric modeling tool sets, which are very cool, but they sometimes lack this realism that you really want to have. And you might have noticed sometimes when you play a game or you see an image, you don't know exactly why it looks fake, but you do know it looks fake. That's what a lot of users kind of have, where we tend to recognize patterns in nature, even though we cannot really explain what we recognize. And that's why we really want to make this a simulation-based approach to capture as much of realism as possible. On the other hand, we want it to be very, very beginner-friendly. So also for everyone who doesn't have any Houdini experience, should be able to make plants at ease. And of course, we have some Apex. A little foliage history. So in the 1970s, it kind of started where we had L systems, Lindenmayer systems. And these were just very mathematical ways to describe plant growth. Then in the 80s, the computing power basically took off. And this is where scientists started to use very, very predictive models to try and predict plant growth. For example, to enhance crop yields. And then around the 2000s, very roughly, more and more studios for movies, for art, tried to make foliage. And this is where parametric design really became large again, because those simulation models exist, but they are very slow, of course, still. And artists really want that iterative feedback. Now, a little background on Natsura. We are using a solver-based solution, and that's also how we want to combine the simulation-based approach together with the parametric-based approach, where we first start with all the different nodes and all the different logic that encompasses the DNA of the plant, and then later we put it into a solver, which is going to solve this recipe. And because we have so much control over this logic and all the rule setup, we really want to maintain 100% of all the control that a parametric solution might provide you. Now, let's just jump in. We have a normal Houdini interface. We modified it slightly for our Natsura users. So people who don't have any experience with Houdini, we've hidden a lot of stuff. And at this point, it's with empty scene. We basically see one simulate node, and we are going to add a grow step. So this is really the core node of the toolset. And if I just place one in the scene, you can see here on the left that I've added basically one little primitive to the scene. And this is where our initial point basically started growing for one grow step. So very simple, one grow step being added to the scene. You can manually try to place multiple grow steps after each other. This probably will become a little bit of a pain, but it shows you that it's possible, of course. This is a very manual workflow, but this way you can also grow your branch. You can see if we have just multiple grow steps, we already get a line which moves upwards. Now we have some settings on all of the nodes. And if we, for example, adjust the node pitch, you can see that we already get this kind of kink. But then if we adjust the roll to be 0, you can see that multiple components being chained together, all of them having a pitch downwards, basically ends up into a spiral. And the node roll, by increasing that, really gives this twisting, kinky nature of the branches. This is one of the ways that we really want to start defining the logic that this branch will have. Now, we're going to remove a couple of these growth steps because we don't really want to place that many manual steps. And what we really want to do is use this repeat block. And it's our own little repeat block, similar to the for loop that you already have in Houdini. And what this allows us to do is to repeat logic. And what we're repeating over here is the logic of this one growth step. And each growth step already has a little bit of a lower length value as well. And we are changing parameters like the pitch and the yaw to get the behavior that we want, that twisting behavior. All right. Well, we are going to introduce an extra node over here. We have the split, and this is where we are going to append more logic, more steps into this equation, where we're now repeating one growth step, which connects to itself, and one growth step branching off. And this is already, you see, the branch starts to look a little bit more interesting. We have some shoot-offs. And now to really zoom in on like what's happening regarding this logic is if we add one extra green node, one growth step in between, you can see that in the viewport, we have this little section of one pink growth step, one green growth step, and one brown growth step. And those three are also in your network view. You can see that those three are the ones that we are basically repeating each repetitive step. And this is where the flexibility is starting to get in, to set up your tools just the way that you want to set them up and get, and this is a very standard behavior, we would say, for a monopodial tree or a monopodial branch. Basically one main branch, which sometimes has a shoot off. Now, let's remove this green one again. And we are going to append a mapping node. And this is where some very, very cool power start to get in. So we click on this grow node. We want to adjust one parameter, and we're going to adjust the pitch parameter. And basically what we will do, and the moment this one clicks, it really helps to understand the system any further. And what this map node does is that we have the pitch, and we want to map it by the U. And the U we get from this for loop. So basically, if we are at the beginning of this repeat block at the bottom of the branch, the U value is around 0. And then when we get to later to the top, the U value will be 1. And so we are mapping the pitch in each iteration to be mapped based on this U value. So the lower portion will become a very low value. So you can see that it's kind of goes straight. And then the higher we come, the more kinkiness we are adding to this branch. Now, the next step, we have a very simple, interesting branching shape. We are going to copy over this logic. As it's a framework, all these nodes connect well together. And what I'm doing right now, I'm also changing the colors a little bit. I'm just copying over the previous logic and placing it later into the system. And this allows us to have these secondary branches now. I basically made the first branch first, and then I copied it over to get the same behavior later in the life of this plant. All right, I'm gonna change a couple of settings just to play around in the system. I'm going to make sure that this internode step length, basically this branch segment length, I'm going to increase it a little bit. I'm also increasing the repetition count. And you can already see that we get a slightly interesting shape. Now, some of very cool stuff that we want to show over here is that it's a simulation. So what we're going to add is on each secondary branch, we're going to add a force, which is going to influence the growth of this plant. And the force that we're adding over here is gravitropism, which is, in plant terms, basically the tendency of this plant in this stage of his life to follow gravity, either up or down. And you can see that we get these nice bended shapes at this point. We have many different vectors that we might want to use. Maybe it's you want to grow to the light. I will show an example later. But there's many different vectors that we have. And gravitropism, of course, a very cool one. Now, a little bit of a different setup. We had one with just like one branch in the middle. But of course, we also have bifurcating setups. So right now I have another grow step. I've wrapped it up in a repeat block. And this grow has the option to not just have one branch, but it can have a branch count of 2. And when we start repeating this might be a little bit reminiscent of L systems. You can see that this plant starts to look a little bit like a L system. Now, we are trying to keep all the stuff performant because many plants actually have lots and lots of tiny branches. So let's increase this to a very high number, to 15. You can still see it's very responsive, and this is around 60K branches. Now, to add a little bit of variance, we want to do a little bit of a length variance. So right now, this is just very random. And we are going to do some mapping again. So we have this growth step, and what we want to do is to get this branch count not to be always 2, but we're going to use a random value and assign that random value to drive it to be either 1 or 2. And this way you get another little form of randomness where sometimes it splits and sometimes it doesn't. Now, all right, going back to our previous example, we want to show the flexibility of the system. So we just made this bifurcating setup, and now this is what I'm going to wire into the secondary branches of the previous system. And you can see it's very easy to swap these types of behaviors. So you could imagine that an artist is working on one branch and then another artist made a different one. They actually like the second branch better, and they just swap it in to get that behavior that they want. Now, next up, to go more into the simulation route, we can, of course, add objects to this simulation. And we have a couple of factors which are interesting for that we want to get. And the first thing I'm showing here is the collision that we have. So if you add an object to this scene, to this solver, you can see that all the plants collide with it and they cannot go through it, which is already nice. And now the really cool one is that we are going to add a little bit of phototropism. So basically we're telling the plant how to react to the light. As a little bit of a backstory on how light is calculated for a plant like this. Normally in your scene, you have just like one distant light, for example, where the sun is coming from, and you do your lighting calculation based on that one point. For a plant, this doesn't really make sense because this plant like growing over a year time, and that sun has been in lots and lots of different places. So we are using more of an ambient occlusion value to figure out how much light each place of the plant gets. And we do have a strongest light source, but it's all a lot more vague regarding where the light actually is. Because of course, if one leaf on 10% of the day is in the shadow of another tree, maybe the other part of the day, it still catches light. So we do want to make sure that we capture that. And you can see over here that this component, these grow nodes, we are right now giving them this vector phototropism to follow. And we are influencing their growth behavior. Now, we can play around with the scene a little bit. We can make sure it's more of a roof above it as well. And the plant acts accordingly to find the most light. Now, there's multiple ways to work with this. Like right now, I've just been showing the complete tree. But because it's a simulation framework, we can, of course, just render out whatever generation we want it to do. This can help you to get the age properly right from the tree that you have. So if you made a nice recipe, you can still get it to be the exact size that you want. It's all very flexible. And here is one of my absolute favorite features. We have the posing. So basically what happens over here is that it first grows to the right because that's where it finds the most light. But now I'm diving manually into the simulation at a specific generation, and I'm pushing it to go to the left. And afterwards, the simulation takes over again, and it grows further to the left. So this is that artistic control that we're aiming for, so that the artist really has all the control that he or she might need. And then another very cool feature that we have is a wrangle for all the Houdini power users. And what this wrangle node basically is, it's a normal-ish wrangle where it runs over points. But we only run this little snippet of code in the exact place of logic of the recipe. So if you just place this before the very first row, that's where it will be executed. This is a very, very powerful thing. And over here, I'm showing an example where in the wrangle, I have a little snippet to find the nearest point on the spline that I also wired into the wrangle. And then using that direction, I'm adding it as a vector to, again, affect this growth step and telling this growth step to, hey, you should actually be moving towards this spline. And this way, we now have a tree following a spline. But of course, with a wrangle, you can just put in whatever you want. Maybe you have a velocity field, maybe some other objects. You can go wild. It's just text. Now, two more nodes that I want to show. We have a lot of different nodes, and this is going to be, we're nearing the end of this little deep dive, because I think it's already a lot of information. And right now what we have over here is a switch. So I've set the switch settings to be based on the height value. And basically this tells the growth step in that moment, in that generation, to switch behaviors. So we have the left input and we have the right input. And over here, if you are below the height of 12, you can see that we're switching to this more flower-like behavior instead of the normal branch that we have. And this way you can add more complex behaviors. And one which is a little bit similar to this is the prune, where the pruning behavior is to basically tell branches, you shouldn't be living anymore. I want to get rid of you. What I'm doing in this setup is that I'm telling this growth step, you actually have a chance of like 30% after 8 generations to die. Very simple setup. But you, of course, you would likely want to link this to simulation values, like did you get enough light, or is there too much strain on this branch? And this way you can see we can already get some interesting shapes. And also very, very important, the width that all these branches have, that's already correctly calculated. So we do get this very nice stumps as well. And now finally, for also something that we're happy with, we are adding more and more documentation. So if you become a user of this toolset, we do have support in that sense. And this setup was maybe not the prettiest, mainly meant to show you guys what's possible. And here is a little video of an actual nice tree made by George. And this is one of the example files that we have in this tool set, where, making a birch. And George, I think, took around an hour-ish to make this tree. And yeah, the goal for us is to really make this foliage modeling intuitive, whilst it being a simulation and being procedural, and really try to stay true to these real-world behaviors, which are very difficult to get by just playing with settings. This is the node network that this birch was, uncollapsed network of 31 nodes. So it's very clean that you can work with. You don't need that many nodes to get very, very complex and interesting behaviors. And we are leveraging Apex. So again, a very big nod to side effects to give us Apex. This is the Apex graph used for this birch tree. It looks humongous, but don't worry, it's very performant. And To explain a little bit about Apex, each node that you see in this graph could either be a large compiled node network, which does a specific task, or it could be as simple as just like one simple vex function. And some of the strengths that we use from Apex are this delayed evaluation, where we can, just like with rigging, we can make the graph of the plant and take a little bit more time to kind of render out the DNA of the plant. And then later we can start messing around with the settings and keep that very, very optimal. Very quick iterations on just changing some random seeds or maybe some sustenance seeds, where the boundary is for the strain, stuff like that. And for me personally, working with Apex, I don't completely recommend it. It's in a very early stage, but it really, really helped me to keep my code clean, where Apex allows you to interject code wherever you want it to go. So I really don't have to bother about these giant for loops anymore, which became very messy, and it became more and more difficult to add any functionality. And that's really, for me, the power of Apex. And it also allows for great flexibility in getting out attributes or getting out whatever we want. Here are some examples. So this is stuff you basically natively have because it's a simulation. We have this ambient occlusion, the light simulation that's being done every generation. We do strain calculations where each branch basically, it gets calculated, like how much force is being put on me. And also like what's the distance of that force to kind of get the strain, which is of course something you might want to use when you're pruning. Because a branch which has a lot of weight, it's very long, might break a bit earlier than a tiny branch. Of course, we have the width, which is done with a very nice, interesting formula. You can, of course, use your own width if you want. You can also add any attribute you want yourself. But this is our native solution currently. We're very happy with those results, trying to be as scientifically accurate as possible. And one custom attribute you might want to make is something like trunk distance. This mainly becomes very handy for LODing, where you don't want to do the distance from the very first point towards the end of your branch, because then you might get this uneven distribution where your LODs at the bottom of your tree might not be the same as the LODs at the top of your tree. So for example, just calculating the distance from the trunk towards the edge of the branches might be very helpful if you have such a system. Let's go to the Natsura roadmap. One thing I'm, again, very excited for is strand modeling. This is basically where lots of plants actually have these tiny little tubes where if there's another branch, another internal tube gets made, and that feeds back towards the main shape. And this strand modeling is mainly to get really gnarly tree shapes. We are planning to do some blending of plant recipes, as we have now Apex graphs, which are the DNA of the tree. And we want to set up some nice utilities to blend between different behaviors. We're going to look further into roots. And of course, we are looking for a wider release. While at this moment, we do have a site where you can apply if you want to be a tester. But currently, we are keeping it relatively small. And we are mainly looking at collaborations with companies who might be interested, as the tools are definitely very, very powerful. And in that sense, they are already in production. So, strands. So here you can very visually see what those strands are. And you can see that basically the system that we want to make is that it makes sense where all these little pipes go and how they really give this character shape to the tree. And over here you can see that the strand lifetime is around 10 before it completely merges with all the other strands that it sees. And this can be, like those gnarly trees I talked about earlier, this can be very helpful to get very, very interesting shapes of trees which have this characteristic. All right. And one more thing that I wanted to mention about strands is that, of course, we have all these little strands right now. And currently it's a little bit to be decided, like how are we going to expose all these settings? But what we do have is that these strands are interactable. So for example, over here, there's a line in the middle, which is kind of pushing out all the strands away from each other to also create a hole. So really to provide these controls for the more artistic user as well. That was the presentation I wanted to give for you. And I think we have some time for some Q&A.
Awesome, Feike. Thanks for taking us through that. Any questions? Yeah.
You nicely showed the object collision. Can I feed a character into that that's moving? How does that?
To rephrase the question, you want to feed a character in it? The character is also moving, or you just want to
No, yeah, basically feed it animation
feed an animation?
as collision.
Yeah.
Or
so,
is that a matter of you convert the whole thing to vellum or whatever you're doing?
So that's like moving objects are definitely possible to get the plant grow on moving objects. One very flexible point is that you can actually also write your own solvers and just interject them. That's the flexibility that Apex provide us, because we basically have this little Vex panel where you can deform it as well. But for a moving object, it's a little bit less exposed at this moment in the toolset. But the goal there is to allow for the deformation in any way you see fit. So if your object is moving, we're just offsetting it again and again and again to fit the nearest position. And for a character, you probably want to map it to a certain type of UV space as well. So you can really nail down the position on the object so it doesn't move around too much. So yeah, definitely.
Yeah, I mean, the obvious use case maybe would be if you do larger vegetation and then you have undergrowth, but you can feed the larger vegetation in as it's growing as the driver for the undergrowth, so that as age happens, light will be available in to different amounts.
Yeah, for sure. So those type of setups we did play with, where we have already a different type of tree, for example, that we throw in, and then we grow ivy around it, for example. Yeah. So good question.
Great. Any other questions? Yeah.
Thank you for a great presentation. I was wondering, some of the pictures had leaves and materials on it. Are you planning to put those systems as well into like the Houdini scene?
So we are definitely going to provide some cool assets in the Overlook setup. Those will not all per se be Natsura based, but we will provide some nice meshing methods as well. And also focusing on how to get those meshes in the easiest way from Houdini to Unreal, as that might sometimes be a little bit of a painful step. So yeah, definitely.
So like commonly, if you're not really, if the game isn't really high spec, we would have to maybe bake the branches into textures or something. So I was wondering if you're planning to do things around, leaves and materials.
Yes, certainly. Like there's many different ways to deal with the hierarchy that you want to set up. Lots of games still use LODs, even though some say you just should use nanite. And you could do a form of imposters if you care about any direction that you want to look at the object. But because we have this entire hierarchy baked in from the start, it becomes very easy to create pointers where we want to start generating from. To tell the system, hey, with a little wrangle snippet, for example, from this point on, I want you to start capturing the rest of the LOD. And then you can bring that to a baker, which then bakes it out. Okay. So, yes.
Thank you.
Anyone else?
Hey, thanks for a wonderful presentation. I have a question about collision as well. In the example that you showed, basically the collision is input in the last step, or basically the first step of the solver, because it works upwards. I noticed that all the strands, leaves, whatever, get basically almost like appended to that collision box. Whereas I would expect trees, in example, when they reach a certain collision, to use that as something to relieve strain on the tree and start growing from that direction as well. How are you solving that?
Yeah, so if we go a little bit back, let me see if I can find a nice little video where we are doing the vectors. There's a couple of options, and here you really have to think about what behavior are you searching for your plant. I think I had it over. Let me go to the graphotropism, for example. Or let's do this one. So we have the phototropism, which is right now being affects every object. So we have collision, where it just doesn't want to move inside of the object. We can also do, for example, a little check with a switch network to tell the growth step to do the behavior only when it's close enough. So we have this figmatropism field, which is basically like an SDF. And if we're close enough to the object, we can now switch behaviors. And some plants kind of have these little hooks and crannies to really stick to the object, but some might want to be close or really, really want to start moving away the moment they are close enough. And this is where we just want to provide you the framework where you have the option to either stick to the object or to already be pushed out like immediately, to only be pushed out if you're very close. Maybe only the main trunk wants to stick to the object, and then the secondary lateral branches will actually be moving away from it. This is where a lot of freedom comes in, where we want to give you that freedom.
Great. Anyone else? Yeah.
With the branch breaking thing, would there be a way to just output that as an attribute instead of having them just disappear entirely?
Most certainly. In this, like if we're talking about the pruning and we don't want to destroy the branch in that sense, that's completely possible. The system actually doesn't destroy it. So the output over here is just visually that it is disappearing, but it's just an attribute which tells the branch, you are not there anymore, you died. But you still have all that geometry. So you could, for example, animate it later on, or maybe you use this prune not in a way that you want it to completely die, but you just want it to stop growing, which would also be possible.
Thank you.
Anyone else? Yeah.
Hey, great presentation. Were there any existing systems that you looked at for inspiration that you found?
Yes, there have been many interesting systems that we've looked at. George definitely has looked at some more systems than I did. We had some very interesting early work of Anastasia Opera, where she really did some very cool simulation-based workflows. We, of course, have our major foliage modeling tool right now, which is called SpeedTree. There are some other cool systems where you have simple tree tools. And of course, we have the growth, and there's many different sculpting techniques as well. And all of those were great material for us to look at, to see what works and what didn't work. And yes, definitely. Still, most of them are still very, very cool to work with.
Anyone else? Yeah.
Oh, thank you for presentation. It's a bit silly question, but can you model roots of a tree in the same way as the branches?
Yeah, if you can model roots in a similar way, yeah, most definitely. So an example that I would love to make, we don't have that currently, but we can input a custom field, for example, where the ground is. We can just wire that into a wrangle and basically tell the growth steps to start going in if they go outside of the ground, because roots tend to want to stay underground because that's why they're roots. So most definitely, it's really about generating any type of branching structure. I personally actually think you can also make rivers with it, but I absolutely have no proof of that yet. But maybe at someday.
Thank you.
Excellent. Well, thanks, Feike. Great presentation.
Thank you.